So I'll start with the session. After that, Saad would continue. Okay, I see the recording has started. So for today's session, we are going to continue with logistic regression. What we are going to cover will be look at uh, what are the we'll revise what we saw last week, logistic regression, and then move to the code part of it. When we are doing this, we'll also talk about one versus all classification method, how we can use logistic regression for this. I'll share my screen. Let me know whether you're able to see it. Are you able to see it?
Yeah, we can.
Okay, yeah. So a quick revision of what we saw last week. Logistic regression, the first classification method, comes under supervised learning. It is an extension of linear regression, but the dependent variable is discrete. It either has values, whether it's binary 0 or 1, or different classes, like it can be take set of values. It's like you can have buckets as the output variable. So for such instances, we use logistic regression. A classic application will be, spam classifier in email, which we have, like, depending on few parameters, we decide whether an email is for a spam or not a spam. An extension of that itself is what you see in a Gmail login. You have like categorization of an email under the primary tab, social tab, and promotion tab. This is also something which is a classification which is not binary. It has got three buckets into which this would fall under. We have one versus for the example which I gave with respect to three buckets. We use the one versus all technique to arrive at the buckets, which bucket a particular email belongs to. So what we also saw was it was an extension of the linear regression. You find the line of best fit and apply a transformation function, which is a sigmoid curve, to get you the result, whether it is a 1 or 0. There are two ways of looking at the result. One is after you've transformed it into with a sigmoid function, you can either look at it as a probability of a particular output happening, or you set a threshold and then you say that above that I'm going to treat it as a particular output value, below that I'm going to treat it as another output value. The cost function for this machine learning algorithm, it will be like different for when the value is 1 or 0. It can be combined into one equation, what you see here. And what we mentioned, we also spoke about decision boundary. The line here which separates whether the output belongs to one category or not, or another category, is called the decision boundary. This was for a single input X and then the output variable Y. But if you look at it with multiple inputs, like, you can have decision boundaries like this. For example, like if you take X1 and X2, two inputs influencing Y, then if you have a distribution like this, then the line drawn here is the decision boundary. It will separate like the buckets which we are looking at. This is for, once again, this is still in the linear area. If you have like polynomial that is coming in, like in this case, if you look at it, if you look at the decision boundary, you'll have to draw a circle here, and everyone knows the equation of a circle is like x1 squared plus x2 squared is equal to something. So here it becomes square of an input. So you can also have such cases, but we'll not look at those details now. So this is a quick review of logistic regression. And then I'll move to the next one, where we are going to talk about feature scaling. This is a concept which I'm going to introduce today. So feature scaling is something which we do not just for logistic regression. We can use it for several other algorithms too. There are a few algorithms like decision tree where feature scaling will not apply, or it's not very useful. So why do we do this? I'll talk about it in detail. Before I go there, I'll show you the data set which I'm going to use for explaining logistic regression today. It's a simple social network add data set. Very simple. I've just taken two parameters, age and estimated salary. Based on these two factors, we are determining whether a person would buy through a social ad or not. That is what we are looking at. So here, if you see, you have like age, which will be 2 digits, salary in thousands, maybe in lakhs, or millions. So you have those numbers here. So what happens is, if you notice here itself, you have a scale which is different. Here maybe the range can be from 0 to maybe 110, or if you're looking at the relevant population, maybe from 22 to 110. Estimated salary can be like few thousands to maybe a million. There are different ranges for different input variables. What happens is, when you give these inputs in the model to the model for calculation, there is a possibility that one particular variable hogs the whole thing because of the range or the dominance it has. So what we do is, we look at removing the range bias with feature scaling. I'll tell you how we do it. That is one of the reasons. The second reason is, when you have numbers which are this big and it goes into the calculation of the model, it's going to take some time for convergence. We know that both linear regression and logistic regression, one of the ways of arriving at the parameters, that is the m value and the c value, is through gradient descent. So we saw that there are several iterations which are run. We find the slope, reduce the parameter and see whether the cost function is getting to a lower value. We find a global minima for the cost function. We have seen that in the previous session. So there's a lot of calculation involved in doing these things. And when you have calculations, when you have bigger numbers, it's going to take more time to converge. So when you do a feature scaling, you can reduce the range of the input variable. One, you overcome the bias of the range of the input variables. Second thing, it will also lead to faster convergence. These two are the main reasons why we'll have to do feature scalings. Any questions till now? Hello?
Yeah, we can hear you. I don't think there are any questions here.
Okay,
Yeah.
Let me just
fine.
confirm.
Right. So I'll quickly move to the techniques. It's we can either do through standardization or normalization. Um, the typical approach would be, if you have a Gaussian distribution of the data, you go for normalization. If it's not there, then you go for standardization. The difference is, standardization, what you do is, you take a particular value. When we say feature scaling, what we are doing is, say for example, we try to scale this particular input. What happens is, you take that as the value, you find the maximum, sorry, you find, have I written it as, yeah, minimum, right? You find the minimum of all these things, subtract it, okay? And you also take the maximum in that range and minimum in that range, find the difference, divide it. So that way you will standardize it with respect to the maximum and minimum. So what I'm saying is, say you take a particular input, that is in this case 19,000, for example. Say, assume that the maximum is, say, 150,000 here, and I'll take the minimum to be, I think it's 80,000, 18,000 here. So what I'll do is, here I'll just take this as 19,000 minus 18,000 divided by 150,000 minus 18,000. Oh, sorry. So it gives you a much smaller value for you, which you can deal with in a better way in terms of calculations. And it will also, if you do this for all the variables, then you're getting it to a similar range level, with which, like, you will remove the bias of one of the input variables influencing the output. So this is standardization way of doing. The other way of doing it is, you take normalization method, where you just take the value, like 19,000, for example, find the mean of all these values, subtract the mean from the value, and then divide it by the standard deviation. This is another way of doing it. There is a link here which talks in detail about feature scaling. I've mentioned it in the slide. When you have time, you can go through this. It talks in detail about what I had mentioned, why it is done. Uh, you know, uh, like this is all gradient descent is the algorithm which we had seen. And for unsupervised learning, it's like you use the distance between two parameters to do the clustering and those things. When that is happening, it shouldn't be that one particular input parameter influences a lot when you're doing that. So that is also an application for feature scaling in unsupervised learning. It's also a reason. Tree-based algorithm, as I mentioned, it wouldn't be very useful, and it talks about what is normalization and what is standardization. Okay, so that's a brief intro about feature scaling. Any questions till now?
Can we graphically see the input values in some sort of graph so that a better understanding is obtained of what exactly we are doing here by this? So I understand that the values are, can get. You may have outliers. That's what you're trying to say here, right? If
It's
I
not just
understood
out.
you right.
No, it's not just the outliers. It is the range in the variable itself. It need not be just outliers. Say if you're if you're taking, say, these two, age and estimated salary, are inputs for the model, right? And
Right.
based on this, you're determining the output. If you have if you have these two variables in different ranges, there is a chance that one particular input influences the output more than the other one. So when you're
Okay.
doing feature scaling, you're bringing them to the same range. Say, for example, I'm just giving an example. If the range is, say, for ages, all these values get converted to -1 between the range -1 to 1, and all the values here get converted to -1 to 1. If that happens, then you wouldn't have any bias that is coming in due to a particular input variable.
Mm. Okay.
See, and in the coding example, which I'm going to do, I'm going to show this in this one too, feature scaling part. You'll see the scaled input too. You'll see the change. Say, yeah, it is from here. It's moving to. If you see this, from here it's moving to this one. Both these variables come to the same range, and this is fed into the model.
Okay. Thank you.
Yeah. Okay. What I'll do is, before I go to one versus all, I'll get to the coding part of logistic regression, how we are going to do that, and then I will come to one versus all again. Okay. As I mentioned, the data set which I have taken is this one. We've taken the social network ads, a person buying through that or not. Say, to make it simple, we have taken two parameters as inputs, age and estimated salary. Based on this, we have data which says like whether the person has purchased or not. This is the set of input which we have. I'll tell you the number of rows we should. Around 400 variables, 400 data points we have. We will split this into train and test set, and we'll build the logistic regression model. See whether we are getting the desired output. And when we are talking about this, I'll also introduce you to the metrics for logistic or any classification technique, which one of the metrics which we use is called confusion matrix, where we find out like what is the true positive, false positive, true negative, false negative. Use based on that we come to some conclusions. We can determine the accuracy of the model. So I'll introduce that to you, and it's all in the code. So coming back to the data, as I mentioned, age, estimated salary input, and you have the output, which is going to be whether the person has purchased through social networks ads or not, 0 or 1, a classification example. Okay, so we'll start with the libraries which are required for doing this exercise. And 1 minute. Sorry, it went a bit too fast. And then I'm reading the data set. I've stored it there. And as we saw in the linear regression example, splitting them into X and Y. I already mentioned this is index location, how you're slicing it. So this means the X index, the row values, and this is the column values. We know that all rows need to be accounted. That's the reason we are just using a colon both for X and Y. And but for column, what we are doing is we are taking all but the last column, and here we are taking only the last column. So we are taking all but last column, which means these two columns. And for Y, we are taking this column. This is the dependent variable. These two are the independent variables or input variables. So we do the split and then use the sklearn library to do the split between train and test set. We are taking, the sizes as 25%. We are taking 75% of the data for, train and training the model, and 25% to check whether the model is working fine. We do this. And I've just printed the X test values. This is for you to show the difference between, a feature scaled one and a one with the data points before doing the feature scaling. So here we take you have the sklearn library, which has the scalar function. What we do is we have the transformation, use these lines to transform whatever variable we want to transform. This will be the input variable. We do it for both train and test. What we need to remember is after we do this and build a model, every time we supply an input, we should remember to do this transformation. That is something we need to remember. So I'll just show you the value of Xtest. I've already printed it. So Xtest after doing the feature scaling here, you can see the range is reduced and it is it's almost similar. Like I think most probably from, let's say, -3 or something to +3. That's the range in which it is. So we have the feature scaled input with us now. What we are doing is we are now using the library to build the model. So we import the logistic regression piece and build the classifier. After it builds, it gives the parameters of this. What we also do is we can just test it out whether the model is giving the output. We just give some random values where the age is 30 and the salary is 87,000. We pass it as the input and we get the output here. Here, according to the model, based on the data which we have provided, it says that the value is 0, which means the person will not be buying in through the social ads. That's what it says. What you need to notice here, we are transforming the input before we send it across. We don't send the raw input across because we built the model using the feature scaled set of inputs. That was just one example which we had given. What we do is we build the predicted Y value. If you remember, what we had done here was we had split the data into test and train. We have the output for the entire data set. So the test size is 25% of the data we had taken. So we have the X test and Y test values which are there. What we are doing now is we build the model with train set of variables, and we have the Y test, which is the actual output. We are going to find out Y predicted, which is the predicted output from the model, and we give that as the input for X test. If you remember, we had already converted the X test through feature scaling, so we are passing it directly. So we have that, and then this is just to show the result both with the predicted and the actuals side by side. This piece of code is only for that. Use a NumPy library to do that. So you see values here. The first column is the predicted value which we have built through the model. The second column is the actual value. This is for the 25% of the data set, around 100 values which you would see. You can compare each and everything and find it, or we can use a confusion matrix and accuracy calculation to find out how accurate our model has been. So this is, I'll introduce what is there for confusion matrix. This is a metric which we can use for all classification methods where we have you have predicted and the actual. So when we say no, we'll take that Y as 0 and yes as Y is equal to 1. Same thing here. The way the matrix appears here, this is not for the data which we had provided. It's just a screenshot from Google. So the numbers will not match. So what we are seeing here is you had the actual no and the predicted no, which is true negative, where for the negative results, the results matched. You have 50 of them. Actual yes and predicted yes. You have true positive, where you have 100 of them matching. So if you see 150 are matching in terms of like predicted and the actual values. If you go by this confusion matrix, and you have cases where the actual was no, but the model predicted it as yes. So you have like 10, and where the actual was yes and the model predicted it as no. So you have around 15 values where the model did not predict it correctly. This is how confusion matrix has to be read. Now I'll show you how it was done, how it behaved for our actual data set. You have the values here. If you see here, 65 true negatives, 24 true positives, and you have like incorrect values, which are 11. So it gives you an accuracy of 89%. You can use once again scikit-learn library to find the confusion matrix and accuracy. You can use this for classification models. This is the coding part of logistic regression. Any questions till now?
Pretty good.
Yeah,
Harsha.
that's good.
Okay.
Pretty clear. Yeah, it's really good to understand the theory and the equivalent code and its functions. It's really good. Top notch. Thanks.
Thank you. Okay. So if everything is understood, then I'll quickly move to one versus all method, where there are several buckets of outputs, not just 0 and 1. I'll tell you how it is being done, even though logistic regression per se is not the only classification method. There are other things and there are other methods which are also preferred. But this is the basic one. We need to understand it very well. So we can also use logistic regression for the bucketing of the buckets of outputs. Like we gave an example, right? If you look at Gmail itself, spam, not spam becomes a normal binary logistic regression, binary classification. But you have multivariate classification, like if you're going to bucket the email into primary, social, and promotion, then it becomes the you use a different method for, or different way of arriving at which bucket a particular set of inputs fall under. So I'll explain how it works. Here I've given a simple example, some random input parameters and an output parameter. Please don't check the validity of this, just random numbers. X1 and X2 having different values. Say if it is, this is the data which we have, like 7 data points, and you have 3 possible outputs, 1, 2, and 3. Okay, you have like if it's 2, 251, 1, 275, 1. If it's all those things have all those all the data points which are there. What we do, how we use logistic regression for this is, we take this table. What we will do is we'll take for the first bucket, that is where the output is 1. We'll take that as 1 and mark all other things as the not desired output, that is 0. Okay. We do the model building based on this. We have model 1 which we built based on this. And then you have model 2. We'll do the same thing for the second bucket. That is, we'll assume all other outputs, the ones which are non 2 to be 0 and 2 as 1. Build the model based on that. Do the same thing for the third bucket. And when you get a new input, feed the new input to all the 3 models. And if you remember when we did logistic regression, I said that it is also a probabilistic estimation right here in this figure. If you see, it's also a probability estimation of what are the chances for an output to belong to a particular category. So if you see here, you will get you have 3 models, and all the 3 models based for one new input, it can give 3 different probabilities. And you take the one with the highest probability and confirm that it belongs to that particular bucket. What I'm saying is you have model 1, model 2, model 3. Okay, and you have new input, for example, like it's just coming in as say 2.5 and say 354. You want to know whether for this set of new input, whether the category will be 1, 2, or 3. You feed the new input 3.5 and 354 into all the 3 models. Whichever model gives you the highest probability, assume that the output is going to be for that particular bucket. This is a way to deal with multivariate classification through logistic regression. I want you to be aware of this.
Question. So when you say
Yes.
multivariant, that means that the output value can only take specific discrete values. It's not a
Yes.
continuously varying thing.
It's not a continuous variable. That is correct. So I'll explain when I say multivariant, it's the multiple possibilities of the output variable. I'm not referring to the input.
They have to be integral values. That's
They'll have to be discrete values. Yes.
Discrete values, correct. Okay.
They're not continuous. Okay. Quick review of what we have seen so far. Logistic regression. We saw what is the theory behind that. What is the transformation function, how linear regression is extended to get you the result in terms of classification. We saw the cost function. Of course, we use the when we are doing the line of best fit, when we're extending linear regression itself, the most prominent method for arriving at the line of best fit is the gradient descent. That is also applied here. And then you apply a transformation, sigmoid transformation. There are other transformation functions too, but we have explained with sigmoid. And then you arrive at the probability of an output belonging to a particular value that you find it, or you can use a decision boundary line to determine whether beyond above this value it belongs to this bucket, below this value it belongs to this bucket. That's an introduction about logistic regression. We saw what was feature scaling, why it is being used, how it will help in the model building, and we saw the code for logistic regression using Python libraries. After we did the coding, we also saw the metric in terms of confusion matrix, which is a prominent metric which we use for classification algorithms to validate whether the model is performing properly or not. And we also saw one versus all, where you have multi-bucket outputs, discrete outputs, how we use logistic regression for this. So with this, we'll stop logistic regression. If you have any questions, please message, or if you have, you can also send an email. I'll be more than happy to answer. What we will do is next week we'll move to unsupervised learning clustering example. Before we go there, I think Saad has some portion left for the housing data, so he'll cover the rest of the session. I need to log off now. I have some work at home. So if you have any questions, get back to me.
Perfect.
Thanks,
Thank you, Harsha. Awesome.
Thanks
so
a
we'll
lot.
get back to you. Thanks.
Yeah, and one last point. I'll not be sharing the Python code. I'm doing this deliberately. You have the recording here. My request is go through it and try to type it on your own. It's for people who are getting into this afresh. I think trying it out on your own is definitely recommended. That's the only reason why I'm not doing it.
Thank you, Harsha.
Okay.
Just a quick update. I still see Dan, Bo, Irene, and Joy, Joey, right? Do not have the Testoper Teams account. So if you want, please type your personal email ID. We will add you into the Teams. Just want to make sure that you do it so you have access to the Teams and you can collaborate before and after the event. Shad, if you can open the Teams and show the the structure, appreciate it. So if you go to Testoper Codeathon and files, please. And then go to certificate, please. Team, just wanted to also mention that we have a minimum criteria of 60% attendance, and those who attend 60% of the sessions, whichever the topic that we have been delivering. So far, we have delivered 5. The Python certification was already been distributed, and the remaining 4 sessions that we did for this year, the certificates of attendance is available inside this Teams at this location. And you are welcome to go and see if you are eligible. You will have a certificate on your name, first name, last name.pdf, and you can take it and of course put it in the LinkedIn and so on. All right. So these are the 2 quick things that I wanted to tell you. And also the team will put the WhatsApp link. We have a closed group WhatsApp link in case because of emergency or any other reason, if you want to cancel the session, or reschedule the session, we normally communicate to that closed group, only those who attend the sessions. So you're welcome to join that WhatsApp link. You would see that WhatsApp link in the that will be posted in the chat of the session. Over to you, Shad, without further ado.
Okay, Kader, I'll log off. Yeah, thanks, sir.
Hey guys, so today, I want to introduce a new data set, and what I want to show is an example of using a pre-built machine learning model to extract information from that data set. These days, a lot of the most high quality models are already pre-built. You can access them through AWS. You can get them through MS Azure. In my case, I'm going to get it through Spacey, which is a library, and there's an organization behind Spacey as well that is constantly working on it and iterating and improving the model. So I want to show you how, firstly, how you can get the data for this data set, and then I'm going to show you how you can apply this Spacey pre-built machine learning model. In this case, what we're going to be doing is we're going to be going through the text data, and from that text data, we're going to be extracting entities. This Spacey as a library is a NLP library. We aren't getting into the NLP stuff yet. We will do that later in the session, but this is more an example of how you can use pre-built machine learning models. And Kader, if you were there in the Python course, I went through the same data set. So this data set is called COVID-19 Open Research Dataset. What this is essentially, it's a collection of all the literature on COVID-19 that has ever existed, right? All the academic literature, and it's being maintained by the Allen Institute. And what they do is whenever new research comes out, they go in and they update this data set. So when I first started using this data set, it was, I think, 11 gigabytes. Now it's like almost doubled. So you can see how quickly this is increasing. And what this basically is, it's just a lot of text files which are made in a certain kind of methodology through which you can extract information. Let me show you the structure of this file, of this data set. So you're going to have one primary folder that we're going to be concerned with, which is document parsers. Within document parsers, it's PDF_JSON. What this means is these are essentially JSON files which contain the PDF text of each individual piece of literature related to COVID-19. Now, the way this JSON is structured can be seen in this document. It's called Json Schema txt. So you can see the kind of information that is available to us in this data set. We have obviously the authors, the name of the paper, a unique ID of the paper. We have the abstract of the paper. We have the exact body of the paper as well. So all the text that is in this academic paper is available to us here. And now what we also have are these. Now, again, if you want to play around with this data set, this will be really interesting. It's bibliographical entries. So basically, you can use this to link different papers together. So this might link to an entry that you also have in the JSON text, and then you can sort of have some kind of network graph that you can make. So it's a really interesting thing to play around with, and I would encourage all of you to if you want to get this data set and just play around with it. I will put the link for this data set in our folder. Now, let me talk about the pre-built training model that we'll be using. In this case, this is going to be the Spacey's NCore Web model. This is the English model they have. As you can see, models for different languages over here. You guys can see the screen, right? I just want to confirm.
Yeah, we can.
Okay. So again, like I said before, these are all as you can see, pre-trained statistical models. There are three options for English. We have a small model, a medium one, and a larger one. You can see how high the size increases as we go from small to large. Like the largest one is 789 MB, the smallest one is only 11 MB. And what Spacey also provides you, because they made it, they know the accuracies of these models. What we're going to be doing is looking at this NER value. It's 85, which is basically the accuracy of this model in terms of detecting entities. It's 85. If you look at the largest one, you can see it's 86. So right, it might look like a small increase, but it actually is very substantial. Because it gets harder to increase accuracy the closer you get to 100.
Yeah. Sad, Partha, what are these models actually for? What are they doing?
Okay, so these models are deep learning models, right? Most pre-built models that you'll find, the advanced one, will be deep learning models. What you can do with these models is you can try to contextually understand the text that you have. So in this case, entities, and I'll show you here. This list is the list of entities that exist in text. So for example, date would be an entity, um, organization would be an entity, and so forth. So for each of these, what we can do is we can use these models to detect these entities in the text. So let's say I have a large document and I want to figure out what are all the people that are mentioned in this document, right? So now what Spacey has done, it has a machine learning model that is going to have a classifier that's going to tell me whether or not a word is a person or not. Right? Similar to the classifiers that Harsha talked about. That functionality is packaged into a deep learning neural network, and we can use it simply by using these models. So in this example, what I'm going to do is I'm going to go over entity detection using uh, Spacey's model.
So when we are using this data set that we looked at before, which is a data set that has all the documents produced on COVID, and then you
Yes.
apply this model to that, any one of them, even the smallest model or the. So what we are trying to find is if I want to find something that mentions, let's say, French language. So I will be able to get all the French language documents, a list of all the French language documents that are in the database. That's what would be one of the outcomes that I will be looking for.
Okay, so in this example, all these documents that you have for COVID-19, they're English, from my understanding, right? I don't know if they were translated probably. What we're going to try to do is, there's no easy way to read this many documents. In this case, it's 200,000 documents. What we want to do is we want to have a way that we can, for example, find for the names of organizations, right, that exist in this text. Or we can find any such information as long as it's mentioned over here. So we can find all the dates that exist in these 200,000 documents. We can find all the quantities that exist in these documents. And again, the use case of you using this will really be dependent on the methodology that you choose to work with this data set. This is just one tool that's available to you.
Okay.
Does that answer the question?
Also, this data set includes just the binary data, or sorry, just the JSON, or there is a binary PDF also involved?
No. So the text from the PDF is extracted, and that text is stored in the
text
JSON
field.
document. Yeah, it's called underbody text. So the entire text that you would have in the PDF is stored over here. So the schema basically explained how they take the PDF, they parse it, and then they fill this JSON document. Any other questions? Okay, let's get to the code part right now. So again, I'll link this out as well. So in my example, I'm only going to look for location, but in your own examples, you can look for all of these different entities as well. And again, this is an NLP model. We haven't done NLP yet. When we will do, you'll understand more about what parsing and tagging is as well. But in this example, we're just looking at entities. Okay, I'm going to run you guys through the code first here. Can you see the font? Do you want me to increase the size?
Yeah, I think it's still visible.
Okay. Okay, great.
Bigger one is appreciated, please.
Okay, yeah, I'll make it bigger. Is that better?
Yeah, it is.
Yep.
Okay, great. So the libraries that again, I'll make this code available to you, and you can follow along with the code as well. So the libraries that we'll be using are going to be Spacey, Pandas, OS, and JSON. These are standard libraries. And then this is the important one. We're going to get Spacey, but we're going to specify to Spacey that we're only working with English over here. And then we're going to load this small pre-built model. TQDM is just for the loading bar, so that's not necessary. In this line 16, I define the path to the JSON documents that we'll be iterating over. I also, well, the other two aren't that important. So now I set the limit to 200. I set a counter and I create a main list called main location list. And now what I do here is I iterate through these JSON documents, and I'm going to take the body text from each document and run it through this deep learning model. Now, this is when you run it through the model, it's automatically going to detect entities within that text. So using this loop, what I can do is I can iterate over those entities and take out the entities that are labeled LOC. LOC in this case means location. And then I take those location entities and I append them to the main list that we have. Now, in the version of the data set that I'm working with, I have I think what's 70 or 80,000 JSON documents. So what set limit here is doing, it's telling this for loop to break when the count is equal to set limit. So in your example, you can just remove this break completely, and you can do this thing for all the documents if you'd like to. But again, in the interest of time, I'm just doing 200 documents. Now, the next part over here is when I was playing around with this, I detected that Spacey separated, for example, if you have United States, that would be separate from the United States of America. So if I want to find out how many times the US is mentioned here, I'll have to get rid of the. So one thing I did over here is I made all the text upper so I can easily detect it, because again, Python in this case is case sensitive. And then I replaced the with nothing. Right? Again, there's a lot more string cleaning that you can do for this. This is just one example here. Then I had all of the entities that were extracted from 200 documents over here, and I wanted to create a graph to see, okay, which one is the most prominent one in these documents and so forth. So I ran this, and this is the result of 200 documents. You can see that Spacey's detected Europe, Asia, Middle East, so all the things that you would consider a location. Now, can you guys see this graph?
Yes.
Yes, we can see it. Yeah.
Yeah, so you can see that there's some values here that don't make a lot of sense. So for example, it just said S is an entity, right? Which we know it's not. But again, we know this is not a 100% accurate model. But the bigger values, it got them correct. So this is an example of the location aspect, location entity detection working. Let me quickly show sort of one more entity. So let's look for. Do you guys have any preferences on which entities you want me to look for here?
What is that cardinal? What does cardinal mean? What is that entity called cardinal?
I actually don't know that, so I'm gonna.
It's a number.
It's a number.
Yeah, should be.
Okay, it may be. Yeah, so it could be numbers that are not in money or percent. It could be like loan numbers, right? We can look for those.
Okay.
Now, even 200 documents takes time, so I'm just going to go through 20 documents. So the TQDM import that I did just allows for this to be visible as it iterates over the documents. One thing I would like to do, I would like you guys to do for this class is to just explore some of the pre-built models that are available to you. So they're available in MS Azure, they're available in AWS, and there are a lot of them available, and they're all available for free in most cases. So it would be really useful for you guys to get a feel of what all is available in these platforms. So yeah, I think you were right about the cardinal. It's basically just loan numbers that exist in the document. So it's 1, 2. So it reads both digits and the word form of the number. So yeah, the only, I guess, homework would be to look at these models and just try them out. And this is a great data set that you guys can use for it. Any other questions? Yeah.
The difference between the small, medium, and large model is only in the amount of input that you're providing it, or what is the that?
So when you load this model, you actually get the entire machine learning model loaded onto your system, right? So a model that's been trained on that has been trained in a way that, for example, there's a lot of features in it, right? So those features that exist will obviously take more size in. So you need to be aware that when you have a bigger model, it's going to take a longer time to load, essentially, because it'll have more features. It would have been trained on more documentation, and the way the feature engineering is done is going to be in a way that the entire model is larger.
Okay, the small, medium, large is the feature set of the model itself.
It's one of the things, right?
Okay.
There could be a lot of other things as well here. So for that, you'll have to look at the exact way they've built this model up. And I think this is an open source model, so you can actually look at that. But the number of features is one of the things that would be larger in the large model. But you would obviously pay for that in terms of the wait time of letting it load. And over here, you can look at the benefit that will have in terms of accuracy.
Yeah. Okay, thank you.
One more question about the accuracy. You mentioned that there is only 1% difference when compared small and large model. Like, is it worth to use large model in that case?
So it depends on the use cases. So if you are, for example, doing this on your own computer, and or you're doing it in an academic way where you just want to get the best analysis for this data set at one point in time, it would actually be worth it, right? But if you're making a web application that is going to constantly use user input and generate an output, then it might not be worth it. So it depends on your unique use cases. In an academic setting, it probably will be worth it, because if you're iterating over 200,000 documents, even the 1% benefit will be a lot. But again, if you're making like a software product where you have to take user input and immediately give an output, it might not be worth it to use such a large model.
And is there any other library or model which has higher accuracy?
There a lot of, for example, Microsoft's pre-built models have some of the same functionality as this one. It might not be exactly the same, but it is similar. So you would have to look into those models and see what their accuracies are. But again, Spacey and all of those, these are sort of market-leading NLP models. So it would be a good thing to research, but these will be the market-leading numbers at this point. And Spacey is is an organization that's constantly updating their models as well. So you can see this release details here. This is the latest version, but you can see that they're constantly improving it.
And one more question, like if I'm not interested in other entities, I'm just, for example, interested in person, for example, can I somehow speed up the model by getting rid of the other entities?
In parsing the model?
Like generally, like not only parsing model, but generally the whole model at all.
Okay, so so the way this is set up, so this loop that I mentioned for ent and doc.entities, only when you run this loop does the program actually go and look for the entities, right? So when I first loaded this model and asked the model to read the document, it didn't do the entity search immediately. So it'll only do the entity search when you iterate over doc.ents. So that's important to know. So if you just use this model for parsing, right, you will not spend time or spend processing power in looking for entities. It's only when you look for entities will the model go and actually look for entities in the document. So yeah,
assume we want to extend or customize the entities. How difficult or how flexible is Spacey on that?
Say that again.
Assume we, just like the previous person was asking, assume we want to say, for example, we want to find out the patients going from, say, for example, symptom to, say, for example, a hospitalization to ICU, right? Right? So something like that. You want to customize the user existing data set, but customize the existing data set so that you want to extract some other information. How far is Spacey or the library is flexible?
So Spacey in this case is going to allow you to detect data in the text which falls under entities, right? It also allows you to parse the data however you want. So you can see the parsing capabilities here. You can parse it based on these conditions, and you can also tag them. So tagging is, for example, I want to detect whether something is a verb, something is a proper noun, and stuff like that. So all Spacey is going to allow you to do is it's going to allow you to gain some kind of understanding of the data. Everything after that, linking the data up, replacing text, that is something that you're going to have to either go to other libraries for or figure out using code. So all Spacey is doing is telling you whether or not what this text kind of means, if that makes sense. Any other questions?
I have a very basic question. Maybe it just shows my lack of understanding.
Oh, no
like
problem.
For this particular use case, why is this deep learning model better than writing a simple program that just looks for countries and matches it against? Because the list of countries is a finite list.
Yeah, that's a good question. So you could theoretically do that, but I'll give you an example over here if it exists. You could have a list and you could just match those, right? But then you would be limited for what's in that list. And more importantly, what Spacey does is Spacey tries to contextually understand how a word is referenced, and then call it as a location. So if a country is mentioned, but it's not mentioned as a country or as something else, then it won't pick it up theoretically, the way it's built. So it just doesn't look at the strings, it looks at the way it's being used as well. And based on the way it's being used, it has a classifier that predicts whether this is a country or not. So that really enhances the capabilities of it. So you could it's difficult to think of an example for a country, but imagine a country's name being used in a way that it's not a country, essentially.
Yeah. Okay.
That is something that Spacey will be able to detect, and just doing a search will not be able to.
Okay. Yeah, and I guess a country is a very simple example. You may have something that the list is not feasible to actually have a list, but based on the context, I guess.
Yeah. So we did the cardinal one, right? So you can't have a search for the word for all kinds of numbers, right? So if you want to look for 500,232 in word format, that's something that you can only do with this. You probably won't be able to do that in a list form. So, yeah.
Thanks.
Sure. Great. Any other questions before we close the session? Okay, great. I'm going to put this code up then, so you guys have access to it. You can run it on your own, and I will put the links for the dataset and the pre-built model as well, so you all can play around with it.
Sir, I have one simple general question.
Yeah.
So this is regarding the coding pattern. So I see on the spider on the black background screen lots of code. So what is the best practice in the way that do you copy some of the codes and then tweak it, or you write everything from scratch and then debug, compile, and check the output? Or what is the best practice? I haven't seen.
Yeah, so this is just a basic script, right? And so if you look at this part of this one here, this is something that I looked up and I just used in this for function, in this for loop. I didn't know that this is exactly how you have to go about looking for entities. So that's something I copied. The rest is it's a very basic for loop that allows you to iterate through a document. And this is not like a program where you need to do a lot of testing. I just created the script and ran it a few times. And I gave you an example of the first time I did it. I got this issue where it was detecting the separately. So the United States was different from United States, right? So I just went in and put this one line of code that replaces the with the nothing. So again, this is more of a script. It's not a whole program. I don't know if that helps answer your question, but it's a mix of both, creating the code yourself and going to Stack Overflow or Google and getting snippets of code that will help you depending on the situation.
Yep, thanks. Thank you so much.
Sure. Great. Any other questions before we end the session? Okay. Thank you, everyone. Have a great weekend, and look forward to speaking with everyone next week.
Thank you.
Thanks. A great session.
You guys have a great weekend. Happy turkey eating.
Thank you. Thanks, everyone.
Thanks. Good
Bye-bye.
session.
Thank you.
Hey guys, remember to promote your friends and colleagues to join us as well.